and this is Physics 2 Lab 2 Lines of Charge. So to begin, the purpose of this lab was to determine the magnitude of electric charge on a piece of tape using a computational model. To calculate the magnitude of this charge on the tape, we will apply the same principles from Lab 1, Newton's second law of motion, and Coulomb's law. Now, in Lab 2, we will distribute charge evenly across the line of tape instead of treating the tape as a point charge. Our procedure for this experiment is the same setup as Lab 1, so we're going to first generate electric charge, then lower the top tape over the bottom tape until the electric force is strong enough to cause the bottom tape to levitate. And we'll measure the separation distance of when this happened, and then we are going to use the data from this experiment to predict the magnitude of the charge on one tape using a glow script model. But in this experiment, we're going to model the tapes as lines and not just as single point charges. So in our setup, the system is the bottom tape and the surroundings are the top tape and the earth. And our experimental data, we found there was roughly 0.015 meters in between the two tapes. This was 1.5 centimeters, and then each tape was 12.5 centimeters or 0.125 meters long. And this mass of the tape calculated using the density is equal to 0.000125 kilograms. And this is just a quick video of the tapes levitating at about 1.5 centimeters. So here's a look at the glow script code. First, we have the initial conditions and functions. We've got physical constants, the K constant and the gravitational constant up in the top right corner. And then the observed values from the experimental data are included here. These were measured in the Lab 1 experiment. And then the estimated net charge on one tape, the initial value from Lab 1 is included, and this was our starting point as I tried to calculate the actual linear charge. And then here is the electric field function, which was the same function calculated in Lab 0. And then here's a look at the model in GlowScript. So first, two tapes were created. This lab had starter code provided, but the starter code considered the forces on the top tape as opposed to the bottom tape in our experiment. And the starter code also assumed that the two tapes had the same charges while our tapes had opposite charges. So to account for these differences, the labels for bottom tape and top tape are just flipped so that the forces will all be opposite and will correctly model our situation. And then also in this first line of code for DQ and top tape, you'll see that I noted that the starter code assumes tapes have the same charge. And so this is why we assign a negative sign to indicate that the charges are opposite. And then the electric field is calculated at each individual DQ step. And then these individual point charges along the line are summed together to get a more accurate E-field estimation. And then also you'll see that arrows are multiplied by scale factors, which are determined through trial and error to visualize the situation. So here's a look at the results. In the picture, you'll see the E-field vectors at each charge DQ, and some of them are pointing on they have a bit of an angle to them, depending on their R vector between the two tapes. And then the electric force is demonstrated by the big white arrow pointing up, and the gravitational force on the bottom tape is demonstrated in the big yellow arrow pointing down. The magnitude of charge on one piece of tape was determined to be 3.391 times 10 to the negative 9th coulombs. And then this was greater than the magnitude of charge that was calculated in Lab 1, which was 5.534 times 10 to the minus 9th when the tape was treated as a point charge. And then you'll see what our glow script shell outputted. So some assumptions made in this experiment were that we ignored air resistance, and we also assumed that each tape had the same magnitude of charge evenly distributed along the length of the tape, no longer considering the tapes as point charges. Possible sources of error in the experiment were the same two factors from experiment 2, that charges distributed to the hands or environment, or charges were not actually equal in magnitude. And then in this experiment, if we had used too few of the smaller point charges, like individual DQ steps, we would not have accurately computed the linear charge. More point charge steps is like more precise and more close to the model of a linear situation. What if we had modeled each tape as a single point charge? we would have gotten a greater value, as we did in experiment 1. Our magnitude treating it as a line is less than the magnitude of the charge treated as point charge. Why do these estimates differ? Because the point charge calculation is a simplified, idealized model, while the line charge model is more complex and more closely describes the interactions between the linear pieces of tape, nearly linear. I believe that the line charge estimate is more likely to be closer to the real value because it accounts for the reality of the situation where the tape is pretty linear, about as linear as a household object can get, and charge is distributed throughout this piece of tape as opposed to being concentrated at the center, like in a bowling ball or something like that. And then here's just a picture to show how these two models differ. In the line charge method, some of the E-field arrows are diagonal, and this is why the overall Q value or electric field value is lower because the charge is not all directly in the negative y-hat direction as it is in the point charge method. And that's all. Thank you.